In this video, we will be using the remainder theorem to evaluate functions. The remainder theorem says, if the polynomial f of x is divided by x minus k, then the remainder is equal to the function evaluated for the value k. For example, let's let f of x equal this polynomial, negative 3x to the fourth plus 15x cubed minus 50x plus 25. And we're going to use the remainder theorem to find f of 4. Now in our problem, k is 4. So in our little box for synthetic division, we're going to put a 4. And then remember that for synthetic division, we just write the coefficients. Now I'm going to point out that we're missing our x squared term in between the x cubed term and the x term. So I need to remember to put a 0 there to hold that place. All right, my x to the fourth coefficient is negative 3. And then my x cubed coefficient is 15. My x squared coefficient is 0. My x coefficient is negative 50. And my constant is 25. Right, I'm just going to do synthetic division, bring down my first number. It's negative 3. Multiply that by 4 and get negative 12. Add these numbers together. Multiply, add, multiply, add, multiply, and add, and this is my remainder. Now the remainder theorem says that f of 4 is equal to this remainder. So this is my answer. Now we could, and I want to just point this out this one time, we could find f of 4 by plugging 4 into my equation. Just substituting it in, negative 3 times 4 to the fourth power plus 15 times 4 to the third power minus 50 times 4 plus 25. Now this is a little bit harder to do, especially if you don't have a calculator. So the synthetic division would be the way to do this. But I want to show you that we will indeed get 17 when we work this out. This is negative 3 times 256 plus 15 times 64 minus 200 plus 25. Negative 3 times 256 is a negative 768. 15 times 64 is 960 minus 200 plus 25. And when we do the math here, we get 17. So we see that, yes, f of 4 is 17. But the synthetic division method for finding that was a lot less painful than direct substitution.